In this video, we're going to discuss completing the square and how completing the square can help us solve quadratic equations. So, before we get to solving quadratic equations, we first need to discuss what completing the square is. So, the idea behind completing the square is to take an equation of the form x squared plus bx and then adjust it so that it is a perfect square. Okay, and so first that needs to be unpacked because we need to know what a perfect square is. And so a perfect square is a quadratic of the form x squared plus 2ax plus a squared. And so that's important to us, or that's beneficial, because we can rewrite that as x plus a squared. Okay, let me make my pen a little bit bigger. We can rewrite x squared plus 2ax plus a squared as x plus a squared. Okay, and so that's going to be beneficial for us eventually when we get to solving quadratic equations, because this is a nice form where we can use the square root method to solve our equation. Okay, but first we need to know what completing the square is. We start with a form like x squared plus bx, okay, where b is any number, okay, and so we identify that term, step one, b. We multiply b by a half and then square the result. So we compute 1/2 b quantity squared, okay, and then that's important because that's creating this a squared term up here. Okay, and then we add 1/2 b squared to our original form, okay, and that's going to get us that perfect square. Okay, so once we do that, then we get the perfect square, which is x plus b over 2 squared. So let's do that. First we need to, we'll start with example number 1, and then we'll go to example number 2. So if we identify the b for this equation, it's 12, okay, 12. Then we need to find 1/2 b quantity squared, okay. So b is 12, so I substitute in 12. Quantity squared, 12 times a half is 6. And so 6 squared is 36. Okay, so that's our 1/2 b squared. Now we add that to our original form up here, okay, to get now a quadratic, and that's a special quadratic because it's of this form that we talked about up here. And so we can rewrite that as x plus 6 quantity squared, okay, which is what we did, or what we were looking for all the way down here. Okay, so that's one example. Now we'll go to a second example over here where there's instead of adding 12, we're now subtracting 5x. Okay, so instead of adding 12x, we're subtracting 5x. So our b here is -5. We could rewrite x squared minus 5x as x squared plus -5x. Okay, if you want to think of it in that way, and so that makes seeing -5 as b a little easier. Okay, then we calculate 1/2 times -5 quantity squared, and 1/2 times -5 is -2.5. -2.5 squared. Okay, when you square a negative number, it turns positive, so the negative sort of goes away, and 2.5 squared is equal to 6.25. 6.25. So I add 6.25 to my original solution up here, okay? And the perfect square becomes x minus 2.5 squared. Okay, so the number inside here, whether it's negative 2.5 or 6, is always going to be b over 2, which you can find right here. Okay, so that's completing the square, just as a concept. Now we can use that completing the square method to help us solve quadratic equations that look something like this. Okay, so it looks rather innocuous. Over here we have number 1 and number 2, and so at first glance you probably think, oh yes, I can factor these polynomials, okay? Or I can factor this quadratic equation, or the quadratic on the left side, and then solve this equation easily. And so your first thought is probably, and what it should be, is to ask yourself, can I factor this like so, and then use the factoring method that we discussed in the previous slides to solve this equation? And the answer is maybe. Okay, I can if I can find two numbers that multiply to negative 13 and add to negative 6. Okay. Are there numbers that do that? Okay. Can I multiply to 13 and then add to negative 6? Multiply to negative 13, add to negative 6. The only numbers that I can multiply, only whole numbers that I can multiply to get 13 are 1 and 13. So that is not what we wanted to hear, okay? Because no matter how you try to slice it, adding 1 to negative 13 or negative 13 to 1, you're not going to get negative 6. So factoring is out. We need to complete the square. So the first step, step 1 of completing the square in this solving quadratic equations setup, is that you need to get rid of this negative 13 here, okay? Because we need the form x squared plus bx. That's what we worked with last time. So we need to get rid of that from the left side, which means we just need to put it over on the right side. So let's do that. Let me get rid of all this stuff here. Okay, so let's put the number without any x's in it on the right side. So we get x squared minus 6x is now equal to 13. Okay, great. Now let's complete the square on the left side. Okay, so we need to find what b is, and it turns out that b is negative 6. Okay, then compute 1/2 b quantity squared. 1/2 of negative 6 is negative 3. Okay, so 1/2 of negative 6 squared is negative 3 squared, and that's 9. Okay, so that's 1/2 b squared. Now comes the part that we didn't do in the last slide, but we need to do here. We have an equation up here, and whatever we do to this equation, and rather we can do this to the modified equation now, whatever we do to this, it must be algebraically valid so that the equation stays valid. Okay, so what I mean is that to complete the square on the left side, what I need to do is add 9, which is what we just found. Okay, x squared minus 6x plus 9. That's going to complete the square for us. But if I add 9 to the left, I must add 9 to the right side of the equation as well in order for my equation to be valid still, okay, or the same as we started with up here. So I can do that, and I get x squared minus 6x plus 9, and then 13 plus 9 is 22. Okay, 13 plus 9 is 22. Then I can, now that I've completed this square, I can rewrite x squared minus 6x plus 9 as x minus 3 quantity squared. Okay, remember it's always b over 2. It's always x plus b over 2 all squared. Okay, here b is negative 6. Okay, and so that is x plus negative 6 over 2 squared. And so it's x minus 3 quantity squared. Okay, so that's where I got the x minus 3 squared equals 22. And I can solve this problem using the square root method that we just talked about. So I take the square root of both sides, and I get, let's move up here. When you take the square root of both sides, you get x minus 3 is equal to plus or minus the square root of 22. Okay, and you can ask yourself, can I simplify the square root of 22? And if you can, then you definitely should. Okay, and if you can't, then you shouldn't, of course. Okay, we're going to keep it as square root of 22 for now, and move forward, and then we'll think about that at the end. So, to get x by itself, you need to add 3 to both sides. Okay, and so the answer is x equals 3 plus or minus the square root of 22. Okay, and so now you can ask yourself, can I simplify the square root of 22? Is anything, any multiples of 22 a perfect square, or the two things that we multiply together to get 22, are any of them perfect squares? Well, there's 1 and 22, no, and 2 and 11, and neither of those are perfect squares. So that 3 plus or minus the square root of 22 is our answer. Okay, so we completed the square here and then used the square root method to get our final answer. So let's quickly do a second one over here. Okay, now I'm going to do this quicker with a little less explanation. So if I have it here, it's probably not going to turn out nice by factoring or anything else. So we're going to try to complete the square by adding 5. I get 2x squared minus 8x equals 5. There's a 2 common to both things on the left, so I can pull that out. And so I get 2 times x squared minus 4x equals 5. And I can divide by 2 on both sides. So we get x squared minus 4x equals, equals 5 halves. Then I complete the square. Okay, b is negative 4. So 1/2 b quantity squared is going to be 1/2 negative 4 squared. That's negative 2. 1/2 negative 4 is negative 2. Squared is 4. So I get x squared minus 4x plus 4. And then remember, I need to add 4 to both sides for it to be valid. All right. X squared minus 4x plus 4 is x minus 2 squared equals 5 halves plus 4. I can change 4 into 8 halves. And 5 halves plus 8 halves is 13 halves. Okay, so 13 over 2. And then again, quickly, the square root method to get us that extra step. So square root of both sides, you get x minus 2 is equal to plus or minus the square root of 13 over 2. Then x is equal to 2 plus or minus the square root of 13 halves. Okay, so there is how you use completing the square to solve quadratic equations. So here's a your turn. Okay, I've already done the first step for you. I've subtracted or I've added the 21 over. Okay, and so I want you to solve this quadratic equation by completing the square.